again, the day is Wednesday, February the 10th. We are looking at 7SP2. My thing moving with Daphne. All right. Can someone read that standard to us for today?
I can represent statistics using various methods with 60% mastery.
Good job. Starting on Monday and Tuesday, we began looking at samples. We discussed several things about a sample. A sample is the small portion that's being surveyed. What's the entire group?
Population.
Great job. So all of us will be the population, but if I'm only talking about the 7th grade students at J.E. Johnson, that will represent the sample. We discussed 2 different samples we can have. What do we know about a representative sample?
You select items from an evenly distributed group.
Good job. Or in other words, everyone has an equal chance of being selected if it's a representative sample. But with that biased sample, what happens?
It's only a group.
It doesn't represent the whole population.
Don't represent the whole population. And I want to say William was saying it's only a certain part of that group. So make sure we're able to identify the 2. We do not want a biased sample. We love representative samples. All right. Someone read that to us.
Data can be represented in various ways: dot plot, box plot, graph, and etc.
Good job. So beginning in 5th and 6th grade, you began looking at data mostly with box plots. And then last year, 5th grade, you looked at some dot plots. 6th grade, you began looking at box plots. And you're confused about what they are, of course, we're going to look at them. Our practice is in its normal position, a normal place. All right, I'm going to go ahead and read the first one to us. It says, a box contains 80 loose white or yellow golf balls. Each student in Mr. Koger's class drew a random sample of 20 balls from the box, counted the yellow balls, and then returned the sample to the same box. Nate calculated the proportion of balls in each sample that were yellow, and then he organized the results in the following table. So we see the different students. They chose 20 balls, and they told us how many of those balls were yellow. And then, of course, they did a proportion of it. So that would have been 6 out of 20 balls. If you put that in the calculator, that'll give you 0.3. So that's how they ended up with the proportion. So drop it down to the bottom, it states, Martha believed it would be easier to identify clusters of data if the results are represented with a dot plot. Do you agree? Who remember what a dot plot is? All right, I'm gonna give you an example over here. A dot plot is where you had the little numbers and then you had dots. Let's say that was 2, 3, 4, 5, and they would give you different dots showing you the values for each. Is it coming back to your attention now?
Yeah.
All right. So Martha wants to say that we can make a dot plot of this data so we can see clusters. Anybody recall what a cluster was?
A group of data.
Good job, William. That's a group of data values grouped together. All right, so would you agree? Could we make a dot plot of this data and it'll show us if we have any clusters?
Yeah.
Yes.
Why, yes. They said explain. All right, so if we do a dot plot, y'all act like y'all scared to talk. Let's look at a dot plot of this actual data, because that's what's coming up in the bottom. All right, look at our values. Let's say we're going to count up by ones. All right. How many had one yellow ball?
None.
2.
One.
Great job. 3.
One.
So up close, the lever actor.
4.
None.
5.
3.
All right. 6.
3. 4.
4.
7.
1.
1.
And 8.
1.
1.
All right. So let's go back to what Martha said. She said that dot plot would show us clusters. Does our dot plot show us clusters?
Yes.
Yes.
All right. We agree with Martha because, tell us why we can agree with Martha. Did all students choose a different number of yellow? Do we have one dot on each number?
No.
Any questions about it?
I'm still typing.
All right, let me know when you finish, Jamal. It's gonna be hard for you to put that dot plot, so make sure it's on paper somewhere and you just snap a picture of it.
Done.
All right, so then at the bottom it asks us, according to the data, what is a good estimate for the number of yellow balls in the box? So think back to our dot plot. So if we had to say how many yellow balls was in the entire box, based on those clusters we had, what can we say?
Well, 12.
Remember, we don't want you to add them all up. Based on how many they pulled, and we did that dot plot, think about how many values had the same amount of numbers. So about how many yellows can we say is in this box?
6.
Why can we say there are about 6 yellow balls in the box?
Because there were more six yellow balls than 5.
More students pulled 6 yellow balls. Great job, Joseph. Any questions about it? Let me make it smaller so I can see it all on one screen. Maybe too small, but okay. A box in Miss Booth's class contains 200 loose white or yellow golf balls. Once again, same scenario. The table below represents the results when 11 students each drew a random sample of the same number of balls. They counted the number of yellows and returned the sample to the box. So very similar to the first example. It asks which graphic representation of the data, a table, a dot plot, or a box plot would best help estimate the number of yellow balls in the box. Now notice in this table, only thing they gave us was the proportion of yellow. They didn't tell us how many yellow balls they picked. They just gave us the proportion. So based on that, do you think we can make a table, a dot plot, or a box plot?
A box plot.
What is a box plot, Jamal?
When you like you put the S's in it.
No. A box plot is something that looks like this. And it has 5 values. Lower value, the highest value, the median, upper quartile, and lower quartile. So you mean tell me we can get all that from looking at proportion? Okay. So when you saw these values for the proportion, what did you think of? Did you think of a table? Did you think of a dot plot?
Table.
Why would you say a table, William?
Because for me personally, it'll be able for me to see it more clearly and help me better understand it.
Okay, I can work with that. And that's more like it. When I see a set of data, I'm instantly thinking of maybe a table or a graph, but I'm definitely not thinking of a box plot. And then down below, they told us create a box plot. As I stated, I just showed you what a box plot is. I did note that a box plot has 5 things, for those of us who may have forgot in 6th grade. The first is the lowest value. We then have what's known as the lower quartile, or in other words, the median of the lower half of the data. The third value is the median. The fourth value would be the upper quartile, or the median of the upper half. And then that 5th value is the highest value. When making a box plot, the lowest and the highest are the easiest to go ahead and place. But looking at our values, what can we count on our number line? What value should we count with? We got 0.6, we got 0.3. What are you noticing that each of those numbers have?
This.
Somebody said the tenths, so yeah, I'm gonna count by tenths. Y'all be acting like you scared to show what you know. All right, it is a little bit, that's okay. All right, the easiest we said we can find is that lowest value and that highest value. What's the lowest value we got?
0.1.
Good job, so that'll be part of our whisker. What's the highest value we have?
0.9.
Great job. How do we find the median of a set of data? Think back to 6th grade. How do we find the median?
The middle number.
What I gotta do before I can just say my middle number?
if it's even, you're gonna have two numbers in the middle. You're gonna have to multiply them together and divide by 2. If it's odd, you're gonna have a middle number, just a singular number or digit in the middle.
All right, and before I can tell what's in the middle, I first need to do what with my values? What's that say?
Least the greatest.
That means before I can tell what my median is, I first need to put them in order from least to greatest. Somebody help us get this order. I know 0.3.
1.
0.5. 0.6. 0.7. 4 times.
All right.
0.8.
How many times?
2.
Twice. 0.9.
All right, so now that we have them in order from least to greatest, count till you get to the middle, or scratch off. So the median is 0.7. We got one number in the middle, and that was because William told us whether it was odd or even how many numbers we would have in the middle. So 0.7 is our median. Median needs a bar. Go ahead and draw your bar. All right, how do we find quartile 1 and quartile 3? All right, so that's where we then find the median of the lower set of the data that's less than the median, and then we find the median of the upper half of the data that's greater than the median. So now, looking at the lower half, count off until we get in the middle.
0.6.
Great job. So that'll be our first bar. All right, and then we would do the same at the bottom.
0.8.
Great job. Then, of course, connect your box, and then connect your whiskers to the box. Any questions about it?
No, ma'am.
All right. Down at the bottom, it says, Lana believes a good estimate of the number of yellow balls in the box is 70 balls. Do you agree? Explain how she may have arrived at that answer. Why do you think she say it's about 70 yellow balls in that box? What did she look at? What did we have that gave us a 7?
You.
Great job. That was our
The
median.
median.
Okay, I'll take it. He the only one that saw a 7. Thank you, Elijah. So I would say Lena looked at the median. All right, now how many total balls do we have in this box?
200.
We got 200 total, and we're trying to figure out the yellow. She looked at the median and said, okay, we'll have 70 because the median was 0.7. So if we use 0.7 as the median with that 200, we can multiply that out and that will give us an estimate. Somebody multiply that out.
Yeah, man.
I couldn't hear you, Kennard.
140.
40.
So do we agree with her?
Mhm.
No.
All right. How many balls could we have had and what she said would have worked? Think about 7/10. 7/10, if I had 100 balls, would give me what value? See, that's why it's important for us to learn. That's why it's important for us to learn numbers and stuff. Had we had 100 balls, that would have worked. So if we end up with 140, that's what I mean. She was thinking of the value of 100. Any questions on it?
I'm still writing. Attention.
All right, let me know when you finish.
I'm still type 2.
I'm done, Miss K.
I'm done.
All right, I think it was another person.
I'm done.
All right, can someone read this to us?
A representative sample of 50 customers at a restaurant is surveyed during a weekend to help estimate what should be prepared for the next weekend. Each customer in the sample is asked which entree he or she ordered. The results are shown in the table. Based on the results, which inferences are reasonable?
Thank you, Destiny.
Choose.
This sample is of 50 people of what they ordered. And we got the different entrees: baked chicken, eggplant, parmesan, grilled fish, pasta with some vegetables, and roasted turkey. So we're going to use the information in this table and the total amount to determine if these answer choices they gave us will be reasonable. Looking at A, it says it is reasonable to estimate that 13 customers out of the first 100 customers next weekend will order baked chicken. How many customers order baked chicken right now?
13.
How many total is in this sample? What's the total of the sample?
50.
50.
50.
So on next weekend, should it be 13 out of 100 customers?
No.
No. If it's 13 out
No.
of 50, it will not be 13 out of 100. All right, looking at B. B says about 20% of the customers ordered eggplant parmesan. How many people ordered eggplant?
10.
And we said we got a total of how many?
50.
All right,
50.
somebody simplify 10 out of 50.
Two over 10.
And as a decimal point 2, as a percent, shift 2 times, what's that percent?
20%.
So will that be true or false?
True.
Great job. All right, looking at C. C says if the restaurant has reservations for 300 people for the next weekend, the chef should prepare about 15 grilled entrees. All right, how many people chose grilled fish now?
5.
So
5.
50 people. And next weekend, they said we can have 300 people. So let's find the equivalent fraction. 50 times what is 300?
6.
All right, so then 6 times 5.
30.
30.
Would this be true or would it be false? Now, we just said there should be 30, but they said it was 15.
False.
Oh, okay. All right, part D says about 66% of the customers did not order pasta with vegetables. How many people ordered pasta with vegetables?
17.
17.
Minus 17 will give us how many people who did order pasta with vegetables.
$33.
All right, and they found the percent, so let's go ahead and find the percent. So that'll be 33 out of 50 people.
.66.
So as a percent, that will be 66%. Great job. All right, looking at E, it says it is reasonable to estimate that 20 out of 200 customers will order roasted turkey. How many people chose roasted turkey now?
5.
5.
All right, so we have 5 out of 50. So if we do 200, let's see what we'll get. 50 times what is 200?
4.
So then 5
4.
20.
20.
would work. Any questions about it?
I'm still writing, Miss Kim.
All right, Kendra, let me know when you finish.
I'm finished.
All right, somebody read number 4 to us.
Gianna wanted to estimate the mean number of words per page in the 180-page book she is reading. Which of these sampling methods give the best estimate of the mean word count per page in the book?
All right, so they told us she got a 180-page book, and she's trying to find the mean. What's the mean? What's another word? Okay, and how do we find the average?
Add all the numbers together and then
Add all the numbers together and
Divided by how many numbers it is.
Let's go back to what I say. If you don't know the vocabulary and know what the question is asking, you cannot answer the question. So now that we know and recall what the mean is, think about those answer choices and think about which one would work. And ask yourself, would it be representative? Should I use the 10 pages that appear to have the most words? Would that be a representative? Nope. All right, A says count the words on one randomly chosen page. So that means out this whole book, I'm gonna pick out one page and I'm gonna count those words and I'm gonna say, oh, all the pages got this number of words.
No.
No.
B says a sample of 30 pages with photographs.
No.
C says a sample of 20 pages because they chose every night page.
Yes.
Yeah.
Use the process of elimination. Even if you have to reread it and ask yourself, well, will that work? Remember, you kind of have to train your mind to do the thinking for you. Any questions about it?
No, ma'am.
All right, someone read to us.
A representative sample of 180 customers in a clothing store was surveyed about how they paid for their purchases. The table showed the responses. Based on the survey results, choose true or false for each statement.
Thank you, Kennedy.
You're welcome.
All right, so number A says, well, first of all, look at what we got. They got a sample of 80 customers and they told us how they chose to pay. So now A says 8 out of the first 80 customers would pay with a gift card. Would you say that's true or would you say that's false? How many people chose a gift card right now?
24, wait,
8.
8.
People in the table. What's the total of the table?
80.
80.
80.
On tomorrow, if they get 80 customers again, pretty much 8 of those gonna pay with a gift card. Would you say that's true or false?
True.
True.
Yeah, I'm gonna say that's true. All right, part B says in a group of 40 customers, it is expected that about 10 would pay with cash. How many pay with cash now?
20.
So that was 20 out of 80. And then they said that we have 40 customers. So it looks like they cut it in half. Half of 20 is
10.
Would you say that's true or false?
10.
True.
True.
All right, C says about 0.3 of the store's customers would pay with a credit card. How many pay with a credit card now?
24.
All right, so that'll be 24 to 80. Somebody go ahead and divide that out for us.
0.30.
Would you say that's true or would that be false?
True.
True.
C and part B says a sample of 100 customers will provide less reliable results. If I put more customers in my sample, will I have less reliable results?
No.
False.
That's going to be false. If anything, it will be more reliable. It'll be more reliable because I now have more choice. Any questions about it?
No, ma'am.
No, ma'am.
All right, we're going to try to make it through 6. Somebody read it to us.
Jamie wanted to estimate the mean word length in her science textbook. She did not have time to count every word and compute the average. So she took a random sample of 50 words. Which of these is the best thing to do to estimate the mean word length in the book?
So she got this science book. She don't have time to count every page. So she chose 50 words. So how can we figure out the mean word length of this book? All right, A says find the average and multiply it by 50. B says find the average and use it as a prediction for the entire book. C says use a smaller sample to reduce the amount of spread and distribution of the averages. D says draw a random sample of 50 words from a different science textbook and compare. Which one would you say we won't do or shouldn't do?
A.
You said A?
A.
Yes, ma'am.
Anything else you wouldn't want to do?
D.
B?
D.
D? Okay.
D.
Yes, I definitely want to choose D. I got to choose another science book and then I got to count in that book too and then compare. No, I ain't doing all that. You only got 2 left, so you should be at home asking myself, okay, I need 2 left. Which one is most reasonable?
B.
B.
Like, don't make it harder than what it is. If they said making a prediction, that's most likely the one we need to go with that sample. I definitely want to do a smaller sample. That's not helping me at all. Any questions about it? As you are aware, we will be returning tomorrow on hybrid model. Everyone should know by now if you are an AA student or a BB student, you will receive your updated schedules this afternoon. Of course, we don't want to confuse you while we are still on our virtual schedule. Today is Wednesday, so definitely make sure you have taken care of your business pertaining to your grades or any assessments or anything you have not completed. As always, if you have any questions or concerns from me, please let me know. Have a great day.
Right,
You too.
see you later. Have a good day.
See you tomorrow.
All right, William.